The next important thing in this chapter are the equations of motion. If you want to read science even after 10, then these are a must know. So it's really easy. The first one is the relation between velocity and time. The second one is a relation between distance and time. And the third one is a relation between distance and velocity. So it's really important to know these three, and only then you can do something. It's good if you by heart them. I'll read it out for you once. V equals U plus AT, S equals UT plus half AT square, 2AS equals V square minus U square. As you should know, S is displacement, V is final velocity, U is initial velocity, T is time, and A is acceleration. There'll be a lot of questions which will be just based on these formulas. You just have to put the values and get the answer. One more thing we should know about this is the derivation of these three things using the graphical method. So I've got the graph here and we'll be deriving it using this graph. First, let us derive the relation between velocity and time. For this, you have to draw a simple velocity time graph with the line starting from somewhere on the y-axis and just a slanted line. It's really important to understand what these portions of the line mean. For example, here OA, this was nothing but the initial velocity written as U. And OE is nothing but the final velocity written as V. And OC is the total time taken to change the velocity from U to V. So now that we know what these portions of the line mean, let us move ahead and try to derive it. First of all, BD can be written as BC minus CD. So we can see BD can be written as full BC minus CD. No problem. Next, BC equals BD plus CD. Let's keep BC as it is and BD also. Now can I write CD as OA? CD and OA, they are both the same, right? So I can write it as OA. Now the next step is BC is nothing but the whole this thing, which is nothing but also this thing. So it's V. BD is BD itself plus OA. OA is nothing but U, as we just saw. So once we get this, let us look at what is acceleration. Acceleration is change in velocity by time taken. So change in velocity over here is nothing but BD, because it's obviously the total velocity minus the initial velocity divided by the total time taken, that is AD or OC. You can write it as anything. Let me write AD first, and then we can write it as OC, which is nothing but the time. So I can send T this side, so I'll get BD equals AT. There you go. Now if suppose this is equation 1, just substitute this in the equation 1 and you will get V equals AT plus U, that is nothing but V equals U plus AT. This is the first equation which we had to derive. So it's really easy. You just have to look at which part of the line means what, and then you just have to substitute V and U wherever it's required. Now let's try to derive the second equation. That's the relation between distance and time. So let's see. Isn't this a velocity time graph? What is the area covered in a velocity time graph? That is nothing but displacement. So to get that displacement, let us find the area covered between these 2 points under this graph. That is nothing but area covered. Now can I divide this area into area of this triangle and this rectangle? Yes. So the triangle ABD and the rectangle AOCD. Now let's see how can I find the area exactly. Area of the triangle is nothing but half base into height. Can I write the base as AD? Yes. Into height is nothing but BD. Plus area of the rectangle is nothing but the product of two sides. That is, I'll write it as AO into OC. Now, as we saw about, different parts of the line mean different things. I'm just gonna substitute those things. AD is nothing but the total time taken, so it is nothing but T. As we saw in the above derivation, BD equals AT. You're supposed to do that part of the derivation again over here. So I'm just going to substitute BD equals AT plus AO, that is nothing but U, and OC is nothing but T again. So you get it. You get UT plus half AT square. And this is nothing but the displacement. So as see, I'm just giving you the basic idea so that you can remember how to do these things. There are a few steps which you're supposed to write. They're just easy. You just have to mention what is what, and then you'll be good to go. Now let's derive the last equation which is required. That is the relation between velocity and displacement. Even here, we'll be using the same graph and the same basic idea that the area covered under a velocity time graph is the total displacement. So let's just do that. Displacement equals area covered. So can I also consider this triangle and rectangle as a whole trapezium? Yes. So do you know the area of a trapezium? It's nothing but the sum of the two parallel sides multiplied by the perpendicular distance between them. So let's just see. It's nothing but AO plus BC divided by 2 into OC. So yeah, it's half of that thing which I told you. So now let's see what's going to happen here. AO is nothing but U. BC is nothing but V. OC is nothing but the time. And you have it divided by 2. Now, previously we derived V equals U plus AT. Yes. Now I can also write it as V minus U equals AT, and therefore T equals V minus U divided by A. So I'm just going to substitute this T over here. Let me just do that. So we'll get half U plus V into V minus U divided by A. Yes. So this is what S is equal to. Now I can take the A this side, so I get, and also 2, so I get 2AS equals, what is remaining is V minus U and 2V plus U. That can be written as, yes, V square minus U square. And there you go. It's the last equation of motion. So they're really easy to derive, but the only thing is you got to write each and every step. Like if I'm taking BC as V directly, I just have to mention that according to the graph, BC is equal to V. So that is why I'm taking it here. And now we are clear with the derivation. Now let's move on to a few examples regarding these equations of motion, and we'll be clear. Let's start with example 8.5. A train starting from rest. Let us write down the data as we read. U equals 0 meters per second and attains a velocity of 72 kilometers per hour. So the final velocity is 72 kilometers per hour. It's always a good idea to convert the speed into meters per second. So as I told you, just a small trick. All you have to do is 72 into 5 by 18. So you'll get the answer as 20 meters per second. Let's keep it there. And in 5 minutes, so the time taken is 5 minutes. 5 minutes is nothing but 5 into 60 seconds. That is 300 seconds. Now let's come to the question. The first thing that they're asking is the acceleration. Let's just write number 1, acceleration. So let's look at what and all we have. We have u, v, t, and we want a. The first thing which comes to our mind is v equals u plus a t. Just substitute the values. V is 20 meters per second. U is 0, so let it go. A we are supposed to find, and t is 300 seconds. So A is nothing but 20 by 300 meters per second square. I can write it as 1 by 15 meters per second square. Isn't that easy? Now, coming to the second part of the question, they want the distance traveled by the train for attaining this velocity. So again, we have the same things, v, u, t, but I want distance instead of acceleration this time. So let's think of a formula which gives distance. Yeah, s equals ut plus half at square. Just put in the values and you get s. U is 0, so this whole thing is going to be 0 plus half. A, we just found it out, it's 1 by 15, and t square, that is nothing but 300 square. You can also use another formula which is nothing but v square minus u square equals 2as. Even then you'll get the answer. So half into 15 into 90000, you'll get 3000 meters, which is nothing but 3 kilometers. You can use the other formula also to get the answer. It only depends on what you have and what you want. Okay, moving to the next question. That is example 8.6. A car accelerates uniformly from 18 kilometers per hour to 36 kilometers per hour in some time, that is 5 seconds. Calculate the acceleration and the distance covered by the car in that time. Okay, let us see what we have over here. Uniformly from 18 kilometers per hour. So u equals 18 km per hour. Again, we can use the small trick, that is 18 into 5 by 18. We get 5 meters per second. It's always important to convert it into meters per second unless they ask the answer in something else. And the final velocity is 36 kilometers per hour. Using the same thing, I'll get it as 10 meters per second. Now, they're asking the acceleration. Don't we know the old formula? It's nothing but a equals v minus u by t. They've given the t also. Let us just write it down. So just put it over here and you're good to go. 10 minus 5 divided by 5, that is 5 by 5, that is 1 meters per second square. Never forget the units. And the other thing they're asking is the distance covered by the car in that time. Let us see what and all we have. We have a, u, v, t. We want s. So again, you can use any formula which you feel comfortable, which has these things. Let me again use the s equals ut plus half at square. All you got to do is substitute and find S. U is 5, T is 5 plus half, A is 1, T square is 25. So you get the answer as 525 plus 12.5, which is nothing but 37.5 meters. Let's solve the last example we have. The brakes produce an acceleration of 6 meters per second square in the opposite direction of motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. Okay, as you can see, we are actually braking the car, so acceleration is going to be negative. A equals minus 6 meters per second square. Now, to stop after the application of brakes, so the car is actually stopping, so the final velocity will be 0, obviously. And one more thing we have is the time taken. T equals 2 seconds. And they're asking us the distance it is traveling. Well, let us see which formula we can use. In this case, we can't use a single formula. First, we have to find U. And to find U, we can use V equals U plus AT. So just put in the values. 0 equals U plus, as acceleration is negative, minus 6 into T. T is 2 seconds. You get U equals 12 meters per second. Now you can use this and then find distance. Again using the S equals UT plus half AT square. Just put in the values and you will get the answer. 12 into 2 plus, actually minus, because of the acceleration being negative. You get half into 6 into T square is 4. So we'll just solve this. So we get 24 minus 12, that is 12 meters. So as we saw, all the examples here are really easy. All you need to know are the 3 equations of motion and just perceive which and all values we know and just put them in there and find the unknown value. But it's really important to know what is given before, and then you write the formula and then you do the substitution so that you don't lose any marks. Circular motion is when the object travels in a circular path rather than a straight line. As we saw in a straight line, uniform motion only meant that velocity is constant. There's no change in velocity because the speed is not changing. So as speed is same and the direction is not changing, velocity also will be constant. But in this case, even if we keep the speed constant, velocity is changing. Now, why is it changing? Because even if I keep the speed constant, at one moment, the object is going in this direction, but the very next moment, it's actually turning its direction to go this side. So every moment, it just keeps turning its direction. It changes the direction so that it can go in a circular path. So as you can see, the direction is continuously changing. So because of the change in direction, we say that its velocity is also changing, but still we call it uniform circular motion when the speed is constant, but the velocity is not constant because of the change in direction. So it's actually being accelerated also because of this change in direction, because the velocity is changing. In this case, we can find the V using total distance covered by time, and distance, as we can see, we can write the circumference 2 pi r, where r is the radius divided by time. This is one thing to know. And yeah, this is called uniform circular motion when speed is constant but velocity has to change because of the changing direction. Now we have finished the chapter of motion. As we saw, it's a moderately difficult chapter. But the only thing you have to remember is the equations of the motion, which are really important, and the graphs. And also, you should have a basic concept between the differences of displacement and distance. Other than that, it's really easy once you know these three things. If you have any doubts, please let me know in the comment section. Please do like and share this video and don't forget to subscribe. Thank you.